Are you feeling curious? What's going on there? Today on Curious Crew,
Just gonna need water. It's hot. It's hot.
things get spicy with some flavorful investigations. Exploring salty science.
Isn't that tasty?
Support for Curious Crew is provided by MSU Federal Credit Union, offering a variety of accounts for children and teens of all ages while teaching lifelong saving habits. More information is available at msufcu.org. By the Consumers Energy Foundation, dedicated to ensuring Michigan residents have access to world-class educational resources. More information is available at consumersenergy.com/foundation. Consumers Energy Foundation, supporting education and building sustainable communities in Michigan's hometowns. And by viewers like you. Thank you.
Hi, I'm Rob Stevenson, and this is
Curious Crew!
Welcome to the show, everybody. We always like to start every episode with a couple of discrepant events because discrepant events stimulate.
Curiosity!
That's exactly right, and I've got some fun ones for you guys. First of all, I need to direct your attention to this towel. It looks like an ordinary towel, and yet this is super fabric. And you might be thinking, okay, what are you talking about, Dr. Rob? Well, I'm going to tell you, I'm going to use this super fabric on this nice big block of ice. This came from a bowl of water that's been in the freezer for a couple of days. I'm going to sprinkle the top of this big, beautiful block of ice with some of my Curious Crew salt. And then I'm going to just place my super fabric right on top, boom, 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 and I'm going to turn it upside down and leave it there for a few minutes. Now I want to direct your attention over to my mystery liquids. I've got a blue one, and I've got a
Red one.
You betcha. Mystery liquids you always have to be careful about because you don't want to just drink any mystery liquid because you don't know what it is. I will tell you that these are safe, and perhaps one of you might get to taste one of them. But first, I'm going to ask you to think about this. I've got a little bit of blue in this little cylinder and a little bit of red in that little cylinder. Now, Adia, I would like to put a little bit of blue into the red cylinder and a little bit of red into the blue cylinder. And I would like you to predict what might happen.
Well, it depends on what the liquids are because they might mix or they might stack on top of each other. It really just depends on what they actually are.
Yeah, because it always depends on what they are. Now, to make my life easier, I'm going to get the blue one closer to the red and the red one closer to the blue. So now let's put some blue in here, and I'm going to try to be really nice and just drizzle it down the side. And I'll put several of these little eyedroppers in there.
I see a change of color.
Ooh, we're noticing a change of color here, and that looks pretty good. And now let's go for some red into the blue, and we'll see what we get. See if I can get some captured in there. And just like before, I'm gonna drizzle it down the side, and we're gonna see what's gonna happen. Look at that. Wait a minute. I'm going back and thinking about Adia's prediction. She thought about some mixing and some stacking, depending upon the mystery liquids. Ooh, I like it. Okay, my potatoes. Xana, what might happen if I place a potato in each of these mystery liquids?
I think they're both going to sink to the bottom.
Let's place this one in the red one first. Look at that, it's sunk. Let's place it in the blue one second. What?
Whoa.
Ooh, it's a floating one over there. That's kind of interesting. So we've got some stackable solutions. We've got a floating and sinking potato. And then we've got some mixed colors over there as Adia predicted. I forgot all about my super fabric. Oh my goodness, I gotta show you my super fabric. I'm gonna turn this over for just one second. And what? That's impressive. Told you it was super fabric. Now, I'm gonna invite 3 of you to do a little scientific modeling to see if you can explain these phenomena by the end of the show. You can use evidence throughout the show to revise your thinking. Who would like to engage in a little modeling moment today? Who wants to do that? Who wants to do that? Ooh. Sarah, Nash, Rashab, you three are going to do that for me. Is there anyone here who would like to taste one of these liquids? Okay, Sienna, I'm gonna let you dip your pinky finger into the blue liquid and you report out, what does it taste like?
Very salty.
It is very salty. Does anybody have a guess what we're gonna be talking about today? What do you guys think? What do you think? Jackson, what do you think?
Maybe salt?
You are correct. We are talking salty science today. So take a lesson from my super fabric. Be sure to stick around.
All right, let's figure this out.
We know that the blue liquid was salt water, but I've been thinking about the red liquid. I bet it was just fresh water, but with red food coloring.
And I was thinking about the super fabric. How did the ice block stick so fast?
Yeah, that was surprising. I wonder what the salt did.
Salt is one of the many natural minerals on Earth, and it's made from sodium and chloride elements. Chemists refer to salt by its chemical name, NaCl. There are many kinds of salt, like table salt, sea salt, rock salt, or salt flakes. And salt is used for different purposes. It's been used for a long time for preserving or seasoning foods, but it also helps regulate your body's water balance and can be effective for killing germs. Amazing! Pass the sodium chloride, please.
Now, when I say salt, what do you think of, Lucy?
Well, I think of the flavor.
The flavor. How about you, Isaac?
Cooking.
Cooking. Okay, Adia.
I think of actual salt itself.
Actual salt. And you're probably imagining something white, but look at the variety of salts that I have here. This isn't all of them. There's lots of different kinds of salts. Now, the amazing thing is you might be wondering, where does the color come from? Sometimes it's from the mineral that would be there with the salt, like in the case of Tibetan rose. That one's really interesting, like this one with Brittany Gray in France. There's a couple more, but I do want to point out to you that there are some here that are infused with other things. I asked you each to select 3 samples of salt, and I noticed that a couple of you selected this one. It's from the Isle of Cyprus, which is black. That's infused with ash from coconut shells, which is really kind of strange. All of a sudden, Adia's like, I don't think I want to eat that. Tastes a little burnt, Dr. Rob. Okay, but we also have this green one here. I think you selected this one, didn't you? The exotic bamboo jade. I think you also did too. That's infused with plants, leaves from the bamboo. So we can infuse different things, even spices, like garlic, or I think you got this one. Did you get the sriracha Thai?
Yes.
Ooh, that's gonna be hot. I'd like you all to investigate these. Use your little hand lenses, and I want you to describe to me, what do you notice when you look at these things?
Look like little crystals.
Little crystals,
See like lots of cubes.
cubic shape. So that is precisely what we're gonna be seeing. That's a commonality with salt, right? Now, that cubic aspect, can it affect the flavor? Not really. Are you ready to taste it?
Yeah.
Okay, choose one. Which one are you gonna do?
The Brittany Gray.
Okay, Brittany Gray. Which one did you taste?
My sriracha.
Oh, she's gonna need water. It's hot, it's hot. Okay, what did you think of your gray?
It's definitely a lot saltier than the regular salt.
It's saltier.
lot.
Isaac, which one did you try?
I chose the Palais Red.
Oh, the Pele Red, yeah. And what did you think of that?
It tastes like regular salt.
It tastes like regular salt. So it tastes like regular salt, but the color makes it kind of pretty. Now, I have taken some ordinary table salt and I've placed it inside this balloon. I'm gonna stretch this neck of the balloon ever so carefully over the neck of this bottle that has a carbonated soft drink. And we are going to let those little cubic pieces of salt drop inside. Are you ready? Safety first. Let's take a look at what is going to happen. Oh dear.
Oh my
Oh
gosh.
dear. Oh dear. Oh dear. Oh dear. It is filling up with fluid. And you might be thinking, what's going on there? Remember that cubic part of the salt that we're talking about? All of those edges are perfect for little carbon dioxide gas bubbles to cling to, and suddenly get hoisted all the way up right into the balloon, and you can see it finally calming down. You can do this with sugar as well, because just like salt, there are lots of edges for those carbon dioxide gas bubbles to cling to and hoist them up right inside the balloon.
There is written evidence that 4,700 years ago, salt was already being added to food to improve flavor and maintain health. Salt was especially useful to sailors on long sea voyages, as they would heavily salt their food so it wouldn't spoil. At first, salt was mined on land, then traded or sold. Now salt is still mined, but it also comes from evaporated seawater. Depending on where it comes from and how it is processed affects its size, shape, color, and taste. Look at all those colored salts.
So I have a question for you. Imagine it is a winter day, and you go outside, and the driveway and the sidewalk are really slippery. What are you gonna put down?
Salt.
Of course, and why do we do that?
To get rid of the ice and make it less slippery.
Okay, that makes a lot of sense. In this investigation, we need to do a little bit of unpacking of what salt does with ice. So, we each have an ice cube, don't we? And I'm gonna ask you to grab that ice cube and put it in your glass of water. Now, as soon as we put that ice cube in the glass of water, it's gonna start to melt. That makes total sense, doesn't it? Because the water is clearly warmer than the ice cube. Now what I'm gonna ask you to do, pick up that little string that I have, a little piece of yarn, and we're gonna attempt to lay it across the side or the edge of your ice cube. And if you have to hang the string off the side, that is perfect. Nice, good job, everybody. Good job, well done. Last step, grab a pinch of salt, and we're gonna sprinkle it on the ice cube and on the yarn. And if you want another pinch, that's totally fine. If you even want a third pinch, that's fine with me too. And we're just gonna let that sit for a minute, because suddenly the salt is gonna start to do some work, okay? I also wanna point out to you, I've got these 4 bowls. I took 4 balloons. I put blue food coloring in the bottom of those empty balloons, and then I filled them with water, and then I froze them overnight. And so I peeled off the latex balloon, and I ended up with this really unusual egg-shaped blue ball of ice. It doesn't look much like that anymore, does it, you guys?
No.
Okay, so what are you noticing, first of all? Just some observations. What are you noticing? Jackson, then you go ahead, Victoria.
So there's like some little divots in the ice cubes, like all over the place.
Nice.
Kind of like it's like sprinkled all over.
Okay, so nice divots all over. What else were you gonna notice, Victoria?
Like Jackson said, it's kind of crinkly. Like it's
Yeah.
the type of texture.
And Rashab, what else did you notice?
Like Jackson said, a lot of little caves in the ice.
It's awesome. Notice how there's a lot more water here and a lot less water there. About 2.5 hours ago, I pulled this one out of the freezer and I sprinkled a tablespoon of salt on top. 2 hours ago, I did the same thing. An hour and a half ago, once again, and an hour ago, a tablespoon of salt on that. So can you tell where I sprinkled the salt on there?
Most certainly.
Why do you say that?
Because we can see that you sprinkled the salt right here, right here.
Excellent. And in fact, once that salt comes in contact with the ice, it starts to melt, of course, just from room temperature anyway. But once we have salt water going on, that water cannot refreeze. And if the salt water is trapped right there, it keeps melting and melting and melting straight down, and we end up with these canyons and divots and texture. Amazing. Let's go back to our string for a second. I want to see if it is possible that mine is going to look at that. Isn't that incredible?
Wow.
Of course, we ended up lowering the temperature enough, and it started absorbing all of that thermal energy right from the string, getting it so cold, it actually froze right to the block. That's an icy lift right there. Amazing.
We usually think of salt at supper time, but did you know salt is also added to the diet of livestock to improve their health? It's true. Salt has other uses too. When water has too much calcium or magnesium, a water softener uses salt to counteract that. so your water doesn't leave limescale stains or dry out your skin. And each winter, the United States drops 15 million tons of salt on streets, driveways, and sidewalks to melt the snow and ice. Salt sure is useful.
STEM Challenge.
So crew, have you had fun today investigating salty science?
Yeah.
I'm so happy about that. Now, we're gonna do a little cooking. Now, normally when we cook with salt, it's always a good idea to start with a little less and you keep adding more until you get to the right flavor. But today's STEM challenge, salt isn't going to be an ingredient in what we eat. It's going to be an active agent in what we create. Oh, sorry. You are going to be creating ice cream in a bag. Are you ready?
Yeah.
Let's get started.
Okay. You want to start pouring? Yeah.
Oh wow, this is very viscous.
Oh, that smells really good.
It does.
The crew is making ice cream. Each table is using these materials: plastic bags, sugar, vanilla, 4 cups of ice, a form of liquid, and of course, salt, which is the catalyst to make the ice cream.
Try to get all the sugar so it tastes extra good. Every drop matters.
What the teams are doing right now is putting all the ingredients in the small bag and squeezing all the air out.
Yeah, that looks like it doesn't got a lot of air.
Now they're placing that small bag into the larger bag with the ice and adding the salt. Now it's time to shake it up.
I'm a pro shaker.
Oh, geez. Come on. I think we have the sugar.
Come on, man, get a workout out of it.
It is really cold.
And this should be fun to watch and quite tasty. So it looks like you're ready to eat and you didn't even wait for me. I see that we've got some vanilla ice cream here. And your team made it out of what did you use, Lucy?
Whole milk.
Whole milk. And what did you guys use?
Half and half.
Half and half. And Xana, what did your table use?
Heavy whipping cream.
Heavy whipping cream. I think it's time to taste it before I let it melt away. Taste it. Taste your own homemade ice cream.
That's so
How about that? Isn't that tasty? What do you think? Oh, she's got another bite already. What do you think of that, Lucy?
It was really good.
Really good. Isaac, what did you think?
It actually tastes like a lot like ice cream, but it's not the perfect texture.
Do you think if we shook it longer, it would get even harder?
Yeah.
Yeah, absolutely right. Xana, what did you think?
I thought that this was actually really good ice cream. The only problem was that it melted as soon as we put it in the bowl.
We wanted it to last a little longer. Again, we got a little over anxious, I think, and putting it in the bowl a little sooner than we needed to. So I tried my own little bag, but what do you notice about it? It's still liquid. It's not frozen at all because I have ice in my bag as well, but what am I missing? Salt. You bet. You need salt as that active ingredient to get it cold enough. Try making your own ice cream in a bag. It's the best you'll ever have. Well, you can take that with a grain of salt.
The crew did a great job making their ice cream in a bag, but you can also try using a hand crank ice cream maker. Pour your liquid mixture 3/4 full into the inner container so the ice cream can expand. Surround the inner container with repeating layers of ice and sprinkled rock salt until the layers are even with the liquid mixture. After 10 minutes of slow cranking, speed up for 5. Add some fruit or berries and churn for 10 more minutes. Ice cream, you scream, we all scream for ice cream.
So did you have fun with that STEM challenge?
Yeah, it was tasty.
It was tasty. Who doesn't love ice cream? All right, we've been talking salt today. And we know that salt can get harvested from ocean water, right? We can evaporate that water out and leave the salt behind. But I was thinking about how can I get the water out of salt water? And there is a way to do it. Desalination. Are you ready? I have right here a pot that I've been cooking some salt water, but inside the pot is not only salt water, but a big bowl, a big empty bowl. I've covered the top with aluminum foil and I placed some ice cubes right on the top. If we get that salt water, so we get some boiling going on, the water vapor is gonna go up and hit that cold aluminum foil, and what's it gonna do?
Condense.
Yeah, it gets cooler, it turns back into a liquid, and in fact, it'll cling to the underside of this and drip into the bowl. I started with an empty bowl. It is no longer empty. I'm gonna carefully move this out of the way. And Xana, take a look inside and tell me what you see in what had been an empty bowl.
Water.
Are you sure it's water? I think she should taste it to prove it. She's already tasted salt water today. Dip your pinky in there and you report for me, what does it taste like?
Normal water.
It's normal water. I took the water out of the salt water. The leftover salt water that's in there is even more dense with salt. Speaking of density, I have 3 glasses right here. I have salt water, we've got some regular water, and we've got some rubbing alcohol. Give that a gentle whiff. Oh, is that strong?
Yeah.
It's like going to the doctor's office. Now, I also have some raw eggs and some ice cubes. I would like you to predict for me what will happen if I put an ice cube and an egg in each of these glasses. I'm gonna let you each predict. Ready? Nash, you get the salt water. What do you think's gonna happen?
I think the ice cube will float and the egg will also float.
Okay, he's wanting to see some floating action. Wow, this ice cube is really cold. I'm gonna put this in carefully, try not to splash. Oh, I'm seeing some flotation going on, and I see some flotation going on there as well. Oh, interesting. Xana, how about the fresh water?
The egg will sink and the ice cube will float.
Okay, she's predicting the egg is going to sink. I'll put it in carefully. Oh, and the ice cube is going to float. And look at that! And notice how large that looks. Oh, I just love the refraction of light. Okay, now we have our smelly little rubbing alcohol. Sarah, what do you think is gonna happen with my egg and ice cube here?
I think the ice is gonna float and the egg is gonna sink.
Okay, let's take a look. We're gonna drop the ice cube in. Surprise. Surprise, they both sink. Now let's think about the density that we're talking about. Salt water, really, really, really dense. These things are gonna float. The fresh water, the egg is more dense, it's gonna sink. And the ice cube is less dense, it's gonna float. Now, surprisingly, the rubbing alcohol, these are both more dense than the rubbing alcohol, so they both sink. So I just use ordinary common salt to make the salt water. Even that can be pretty egg-citing.
We saw how the salt got left behind during the evaporation process in the desalinization investigation. You might have experienced that yourself if you ever went swimming in the ocean. First, you likely noticed how you were more buoyant in the salty water. And after you got out of the water and dried off, salt flakes were left on your skin. The salt flats in Utah are a good example of salt left behind after ancient seawater evaporated. Even today, evaporation is a great way to harvest salt right from the ocean. Now that's a lot of salt.
So I've been thinking about density columns where liquids will stack on top of each other based on their densities.
Oh yeah, and water is less dense than the salt water. That would explain why the red water was stacked on top of the blue water.
Exactly. But when the salt water was put on top, it fell to the bottom and the colors mixed into a purplish shade.
Yeah, we also saw how in the icy lift, Dr. Rob's string managed to pull up the ice cube, like how in the super fabric, it managed to pull up the brick of ice.
So crew, did you have fun investigating salty science today?
Yeah!
That is excellent. Now, I hope I didn't pour salt in anyone's wounds earlier with these phenomena, but I know you've been thinking about them. So what have we figured out about the stackable solutions, Nash?
Well, the blue salt water is denser than the red water and the potato, which makes the red water and potato float on top.
Right, so the salt water is gonna sink and the fresh water will float to the top.
Excellent, so you outsmarted me again, and you know that this is in fact fresh water with just some food coloring in there. And Adia's prediction was spot on. We ended up having a mix over here, and that's simply because that salt water is so dense, it sinks right through the fresh water, it mixes the colors together, and here we can see that the salt water is much more dense than that fresh water. So what have we figured out about my super fabric, Rashab?
We know that salt lowers the freezing point of water, so as the block began to melt, the salt water couldn't refreeze.
Right, as the cloth got wet, it got cold enough to freeze to the block.
Great thinking, everybody. So you are right, Rashab. As soon as we get that salt connected with water or ice, it actually lowers the freezing point. It's called a freezing point depression. And amazingly, once that salt water is in action, those molecules are clustering around together, and the sodium and the chloride will not let the water molecules link up, crystallize, and refreeze. But instead, they keep getting colder and colder and colder until it's below 0 degrees Celsius, and it starts absorbing thermal energy from everything around it, including my towel, which then freezes to the block. So it's really not that super, it's just an ordinary towel. But once again, the crew is absolutely worth their salt. So remember, my friends, stay curious and keep experimenting.
Get your curiosity guide and see more programs at WKAR.org.
Support for Curious Crew is provided by MSU Federal Credit Union, offering a variety of accounts for children and teens of all ages while teaching lifelong saving habits. More information is available at msufcu.org. By the Consumers Energy Foundation, dedicated to ensuring Michigan residents have access to world-class educational resources. More information is available at consumersenergy.com/foundation. Consumers Energy Foundation, supporting education and building sustainable communities in Michigan's hometowns. And by viewers like you. Thank you.
So I apologize for that. I'm gonna do a slow-mo move to the camera. Something. Good. And I was loving the eye contact, man. I got you. Oh, I want to show more and more things. Sorry.